Consuelo, everybody! Oh my! This is going to be exciting. I just can't wait. Hopefully you can't either. Want to remind you, this statement right here, okay, right here, it's division that solves the problem. Okay, let's get to it. All right, so factor completely and list the zeros. All right, so first of all here, what do we want to do? Well, there are 4 terms here, so we're going to try grouping it. You can try grouping it all you want. It's not going to factor. So what do? We need a list of things to divide by. So we've got plus and minus 1 and 2. That's from the constant. And from the leading coefficient, we get plus and minus 1 because the leading coefficient is just 1 out there. Okay, so the P over Q list is going to be plus and minus 1 and 2. Okay? Now, I don't have a lot of space here, so I'm probably going to divide and just erase the ones that don't work. Okay, but let's just see what happens. So we've got 1, 3, negative 11, and 2. Okay, so let's try 1. So let's see what happens. So we got 1, 1, 4, 4, negative 7, negative 7. That's not going to give me that. So it's not going to give me 0. So let's get rid of that. All right. And on paper, you'd have more space. So, you know, because this Apple pen writes very fat, so it's hard to write much. Okay, so let's try negative ones. We've got 1. And the division, I'm just going to rip through because you should know how to do this. 1, negative 1, 2, negative 2, negative 13, 13. And that's not going to give me 0. Okay, so let's get rid of that one. All right, so the next thing we'll try is 2. So we have 1, 2, 5, 10, negative 1, negative 2, and 0. Okay, there you go. So we've got P of x equals x minus 2. That's the divisor. And the quotient is x squared plus 5x minus 1. Okay, now what do? We take this and we try and factor it by inspection, but we can't, so we'll use the quadratic formula. So we have negative 5 plus and minus the square root. Let me give myself a little more room here. Negative 5 plus and minus the square root of 25 minus 4 times 1 times negative 1. And that's all over 2 times 1. Okay, so what do we have? We have P of x equals x minus 2. That was the divisor. And now these are the factors of what was the quotient. X minus the first one, which is negative 5 plus square root of 29 all over 2. And x minus negative 5. I'm going to run out of space here. Okay, I'm just going to write it a little over here to the left. P of x equals x minus 2 times x minus the first thing from the quadratic formula. And x minus the second thing from the quadratic formula. Okay, and then what are the zeros? So those are the factors. What are the zeros? The zeros are 2. And again, as I've always said, I don't mind if you write negative 5 plus and minus the square root of 29 over 2. But I want to point out, you can't do that for factors. The factors, each Each zero needs its own factor. You can't write this. Well, you can write it, but it'd be wrong. You can't write x minus negative 5 plus and minus the square root of 29 over 2, okay? That's not acceptable. Let me tell you why real quickly. Let's say you happen to have two zeros, and they were 5 and 9. Could I write x minus 5 comma 9? No, you'd have to write x minus 5 and x minus 9. Each zero needs its own factor, okay? So anyways, that's it. All right, let's take a look at problem number 2. Again, it's 4 terms, so if you start making your K over A list, you're totally wasting your time. Why? Because you haven't looked to see if this factors yet. Remember, this is what you do. This whole, not K over A, sorry, P over Q. This is what you do. Division is what you do when you can't factor by inspection. But look at this. If I put the first two together, I can take out an x squared, and that's 2x minus 1. I can take out a negative 5, and that gives me 2x minus 1. And then f of x equals the greatest common factors, 2x minus 1. And then this gives me x squared minus 5. There's no need to use division here. Why? Because it factors by inspection. So this is 2x minus 1. And then this gives me x minus square root of 5 and x plus square root of 5. We're done. Okay? And then what are the zeros? The zeros are 1/2 and plus and minus square root of 5. Okay? By the way, I want to point out something to you. Why is this called the rational root theorem? You know, the whole P over Q list thing? Because it only gives you possible rational roots. It's no good for it's no good for irrational roots, and it's no good for imaginary roots, complex roots. Okay, let's take a look at number 3 then. This one's probably going to be a little more complicated because I've given myself a little more space, I guess. All right, so let's take a look at it. Okay, this doesn't factor by inspection, so let's make a P over Q list. So the constant will give me 1, 2, and 4. Okay, the leading coefficients just plus and minus 1. I'm keeping this fairly simple at the beginning. And then the P over Q list will be plus and minus 1, 2, and 4. Okay, let's divide. 1, 1, negative 15, 16, and 4. By the way, I want to point out something to you. I just want to remind you of something. Let's say, for example, that this 16x hadn't been here, which it is, but remember, you'd have to put a 0, right? You've got to have every exponent represented, okay? So if it was missing a 16x, you'd put a 0, and if it was missing the x to the third, you'd put a 0 where the x to the third coefficient is. All right, so let's divide. Let's go for 1. Okay, so we got 1, 1, 2, 2, negative 13, negative 13, 3, 3, 7. Okay, that one doesn't work. You know, and if you think this is tedious, I'm not going to disagree with you, but it's better than a total guess and check, right? If I get through these 6 numbers, okay, well, I know there are 4 zeros. I know there, because the degree is 4. I know there are 4 zeros. I know there are 4 factors, but I'm not going to be able to find them. Okay, so let's go for negative 1. So we've got 1, negative 1, 0, 0, negative 15, 15, 31, and negative 31. That's obviously not going to give me 0. So let's get rid of this stuff. Okay, let's try 2. So we got 1, 2, 3, 6, negative 9, negative 18, negative 2, negative 4, and 0. Good. Okay, so what do we have? We have g of x equals divisor times quotient, x minus 2 times x cubed plus, 3x squared minus 9x minus 2. Okay, well, let's continue factoring the quotient then. Now, the quotient doesn't factor by inspection. I wish it did. I would factor by inspection if it did, but it doesn't. So let's try dividing again. But notice what we're dividing here. We're not dividing into the original one. We're done with the original. We're factoring this thing now. Okay? So we've got 1. We'll put the number in a box in a second. 1, 3, negative 9, and negative 2. Now, do you have to go through the entire P over Q list? Well, 1 already didn't work. You know, back up here when we first did it. So it's not going to work. We already know it doesn't work. Okay, negative 1 doesn't work. We don't have to try it. Do we have to try 2? Well, yeah, because maybe 2 could work twice. Maybe it's a double root. Maybe it has a multiplicity of 2. So let's try it. And if that doesn't work, then we'll try negative 2. If that doesn't work, we'll try 4, et cetera, et cetera. Okay, so we got 1, 2, 5, 10, 1, 2, and 0. So you always have to start off, you know, on the second time, you always have to start off with whatever worked before, because it might work twice. Okay, so now what do we have? We have g of x equals x minus 2. Now, where does that x minus 2 come from? Not from the division we just did. I'm carrying it down from the previous step. Okay? So that is the first x minus 2. Now we write divisor times quotient. X squared plus 5x plus 1. Okay? Now, we try and factor this by inspection. If we did, that'd be great, but it doesn't. So what we're going to do is use the quadratic formula. So we have negative 5 plus and minus the square root of 25 minus 4 times 1 all over 2 times 1. And now we'll write g of x equals x minus 2. And you can write x minus 2 quantity squared. I'm only writing it twice to emphasize that it was a 0 twice. And now we have x minus the first thing from the quadratic formula. And x minus the other thing from the quadratic formula. Okay, now we'll list the zeros. And the zeros are 2, which has a multiplicity of 2. And I didn't ask you to tell me that, but you know, we know there should be 4 zeros here, so it's probably good to write that just to keep it straight for yourself. And then negative 5 plus and minus the square root of 21 all over 2. So there are your 4 zeros. Okay. Whoa, looks like I've given myself some room here on this one too. So this one's probably going to be kind of long. Okay. So let's take a look at the P over Q list. So P is going to be plus and minus. So we tried, in fact, this by inspection, it didn't. So P is going to be plus and minus 1 and 2. Q is going to be plus and minus 1 and 3. So we got P over Q is plus and minus both those numbers over 1, then both of those numbers over 3. So that's 8 numbers. Okay, so we have 3. Now it's just divide. Again, if you're not dividing, you're not doing what you need to do. I mean, how many times have I said that? Okay, so let's put in 1. Okay, so we have 3, 8, 8, 1, 1, -2. We lucked out. Okay, so now let's write the factors. Again, immediately write the factors. Okay, don't keep dividing soon because we might not need to. Okay, so we have k of x equals the divisor, which is x minus 1, times the quotient, which is 3x cubed plus 8x squared plus x minus 2. And I'd look to factor that by inspection, but it's not going to, so we'll try dividing. Okay. Now, let's try 1 again, because maybe 1's a double root. So we have 3, 3. No such luck on this one. Okay, so let's get rid of that. All right, then let's try, what would be the next one? -1. Okay, so we have 3, -3, 5, -5, -4, 4. And no such luck on that one either. So let's get rid of that. We'll try 2 next. Okay, so we got 3, 6, 14, 28. I don't think this one's going to work. 29. What's that? 58. Yeah, that's not going to give us 0, so we can get rid of that. And let's try -2. So we have 3, -2, 6, -12, -11, 22. That's not going to give us 0 either. Okay. So what's next on our list here? So we've gone through plus or minus 1, plus or minus 2. So let's try 1/3. Okay, so we got 3. That'll give us 1, 9. And then 1/3 times 9 is 3. Seems like I'm doing something weird here. Okay, so we got 3, 8, 1, -2. Okay, so we got 3. 3 times 1/3 is 1. 8 and 1 is 9. That'll give me 3. That'll give me 4. That'll give me 4/3. And that's not going to give us 0, so skip that one. Okay, so let's try -1/3. So we have 3, -1. It's going to give us 7, -7/3. What's -7/3? Plus 3/3 is -5/3. And then that's going to give me positive 5/9. And definitely that is not going to give me 0, so I can get rid of that one. You know, if you think this is bad, you know, just do it by random guess and check. See, if I get through all 8 of these numbers, then I can just quit and say, it factors, but I won't be able to, I don't know how to factor it. Okay? So what are we at? I already tried -1/3, right? Yeah, so let's go for 2/3. Okay, so we got 3, 2, 10. Okay, what will that give us? 20/3. And then that would be plus 3/3 is 23/3. And then that'd be 46/9. And 46, okay, that's not going to work. Only one more to go. You know, the worst is when all of a sudden, like, you go through all this and just none of them work. So let's try -2/3. So we got 3, -2. So that would give us 6. And then that would give us -4, -3. And that will give it, and that one works. Lo and behold. So we have k of x equals, the first factor was x minus 1, which I'm carrying down from the previous step, okay, times x plus 2/3, and then times 3x squared plus 6x minus 3. Okay, let's keep going. Now that does factor though, because I can pull out a 3. Remember, always look for the greatest common factor first. Difference two squares are trinomial or perfect cubes. So this does factor by inspection. So I can pull out a 3, and I'll put that 3 in front in a little bit. So we have x squared plus 2x minus 1. Okay, well, x squared minus 2x plus 2x minus 1 does not factor. So what are we going to do? It's a quadratic, right? If it was degree 3 or greater, we divide, but this is quadratic, so we use the quadratic formula. You can only use the quadratic formula once you get it to be squared, to be quadratic. So you can't use it on the original problem. You can't use it on the 3x cubed. You can only use the quadratic formula when you get it down to be squared. So we have negative 2 plus and minus the square root of 4 minus 4 times 1 times negative 1 all over 2 times 1. Okay, so what does that give us? Negative 2 plus and minus the square root of 8 all over 2. Well, that we can simplify. Negative 2 plus and minus the square root of 8 is 2 square root of 2 all over 2. Now, you can't cancel it as it is right now because of the plus and minus, but I can factor out a 2. And that would give us negative 1 plus and minus square root of 2 all over 2. And now these 2's can cancel. So what do we get as factors? K of x equals, okay, and I'm going to stick this 3 in front. And then x minus 1, x plus 2/3, x minus the first thing from the quadratic formula, and x minus the second thing from the quadratic formula. Those are the 4 factors. And then what are the zeros? The zeros are 1, negative 2/3, and negative 1 plus square root. I'm going to write this one out. I always abbreviate them, but just so you understand. And if you write negative 1 plus or minus square root of 2, that's fine with me. Okay? So those are your 4 zeros. Okay, now, I've kind of shown so much work here, I kind of obliterated the area for number 5, but let's take a look at number 5. Okay, first of all, greatest common factor? No. Difference of 2 squares are trinomial? Yeah. So we have m of x, so there's no need to divide here. First term, last term, check with the middle. Don't forget how to factor normally. So x squared times x squared gives us x to the 4th. What would give us negative 38? Again, this is just going to be trial and error, but it looks like negative 19 and plus 2. And that would give us a negative 17 in the middle. Okay, so then we'd have m of x, I hope I have space here, equals, this will be x minus square root of 19 times x plus square root of 19, and x plus square root of 2i, and again, why do we need the I? Because there's a plus right there. And x minus square root of 2i. All right, those are the factors. Again, this factors by inspection. So there's no need to divide. As a matter of fact, you'd never find these by dividing. Why not? Because none of these are rational numbers. These 2 are irrational, and these 2 are imaginary. So again, make sure you always look to factor by inspection first. Okay, so then what are the zeros? The zeros are going to be square root of 19, negative square root of 19, or you can put plus and minus square root of 19, minus square root of 2i, and square root of 2i. Or you can put plus and minus square root of 2i. That's fine. Okay? I probably put that problem there because I knew it wouldn't take up much space, and number 4 was going to take up a lot of space. Okay, let's go the last problem. Oh, good, and I've got tons of room here. Okay, so last problem. Let's go for, I can't factor this by inspection, so the list of P is going to be plus and minus 1 and 5. Okay, Q is going to be plus and minus 1, 2, that's the leading coefficient, and 4. Okay? And by the way, it's fairly simple why this works, where this P over Q thing works. And I'll explain it in class, just not here, because it's easier to explain in person. Okay, so let's make a P over Q list. So we get plus and minus 1 and 5, 1/2 and 5/2, and 1/4 and 5/4. So there are, what, 12 numbers here. All right, let's go to it. So we have 4, 16, 33, 23, and 5. All right, let's try 1. So we got 4, 20, 23. This is not looking good. 53, 76, 76. That is not going to give us 0, so we'll get rid of that. So we'd have 4, -4, 12, -12. What's that, 21? -21. 2, -2, and 3. I thought that one was going to work, but it didn't. Okay, so we've gone through everything with 1s. Okay, let's try 2. So we got 4, 8. What's that? These are all going to be huge numbers. 20. What's my pen doing? My pen is doing something weird. Okay, 24. 48. I think you can see this is going to be a large number, then that's going to be large. I mean, you can go through it if you don't believe me, but I can tell this is not going to be 0. Okay? So I'm going to skip that one. Because you're just going to end up getting a bunch of large positive numbers. Okay? Let's try -2. So we have 4, -8, 8, -16. What would that be? Let's see, that'd be 17. -7, -34. So that would be, what, -11? And then that would be 22 and 27. No good yet. Okay, so we've gone through 1 and 2. All right. Let's try 1/2. So we have 4, 2, 18, 9. What's that going to give us? 42, 21, 44, 22, and that's not going to give us 0 either. And you're saying, boy, this really is a lot of fun, Mr. Lieblang. I wish we could do this every day. Okay, so let's try -1/2. So we have 4, -2, 14, -7, 26, -13, 10. Ooh, bingo, I think. -5. I was scared there we were going to have to go for quite a while. Okay, good deal. All right, so let's write, so we've got R of X equals divisor times quotient, X plus 1/2 times 4x³ plus 14x squared plus 26x plus 10. Okay, now that factors, we can pull, what, a 2 out of that at least. And I'm gonna put the 2 in front just right now. Okay, so we've got what? 2x cubed plus 7x squared plus 13x plus 5. Okay, and my pen's doing something weird again. Okay, that doesn't factor though, so let's try dividing with that. Now, we've already tried a ton of stuff, right? We've already tried 1. That didn't work. We tried, I just realized something. Did we ever try 5? I can't remember. I might have blown it and tried 2 instead of 5. But anyway, you get the idea. We've tried 1. It didn't work. -1 didn't work. Yeah, I can't remember if we tried 5 or not. Anyway, I apologize if I made that error. But in other words, if I went back and did it, I stuck in 2. I don't know why I did 2. But anyway, 1 doesn't work. You can go back and try it. We've already done it. -1 doesn't work. 5 doesn't work. -5 doesn't work. Half didn't work. So -1/2 worked once. It might work a second time. Okay, let's try it. Okay, so we got 2, -1, 6, -3, 10, -5. Good deal. So that works, for which I'm very thankful. Okay, so we have r of x equals the 2 that was in front, the x plus 1/2 from the first time we divided, the x plus 1/2 from the second time we divided, and then we have 2x squared plus 6x plus 10. Okay, now what happens? We can take another 2 out of that, and I'll stick it in front. So we have x plus 1/2, x plus 1/2, and we had taken a 2 out of this, so we got x squared plus 3x plus 5. Okay, now, that does not factor, so what do? It's quadratic. We don't have to divide anymore. We'll just use the quadratic formula, so we have -3. Oh, why am I putting it up there? I've got plenty of space. All right, so we've got -3 plus and minus the square root of 9 minus 4 times 1 times 5 all over 2 times 1. So that's -3 plus and minus, and 9 minus 20 is -11. So that's -3 plus and minus square root of 11i all over 2. Okay, so let's write out all the factors now. So we have r of x equals, now I'm going to combine the two 2's and call it 4 times x plus 1/2 times another x plus 1/2. So I'm going to call that squared, right? It's x plus 1/2 twice. And then we have x minus -3 plus square root of 11i all over 2, and x minus -3 minus square root of 11i all over 2. Those are the factors. And what are the zeros? We have -1/2, and that's a double zero or multiplicity 2. And then we have -3 plus and minus the square root of 11i all over 2. Whoa, that's a mouthful. When it all comes down to it, what is it? Divide and get a remainder of 0. If you're not remembering that, you're not remembering anything that's worth remembering. Everything else I've said all depends on that. I don't know about you guys. I'm tired. I'm going to go take a nap. Have a good day, everybody.